Hello everyone and welcome to this presentation on the stack data structure. I am Palak B. Thakkar, lecturer at Government Polytechnic Bhuj. Let's explore what stacks are, how they work and where we use them. And this is also the outcome of today's session. So basically stack is a linear data structure in which elements can inserted as well as deleted from one end. There is basically two policy, last in first out and first in last out is used in stack data structure. It behaves like a stack of plates where the last plate added is the first one to be removed. Just take an example. Here as we see, this is the first plate where we put anything, right? On top of that we put the second plate and on top of the second plate we put the third plate. In same manner when we put the third plate and after that when we want any plate we will remove the last one which we put it over there. So in this way stack is used. Stack are generally fixed size and we can implement them in many languages such as C, Java or Python. So pushing an element onto the stack is like adding a new plate onto the top. Popping an element removes the top plate from the stack. A stack is an abstract data type with predefined capacity, which means that it can store the elements of a limited size. So basically here is the stack representation. When there is nothing, no element in stack, it is called as empty stack. When you are inserting any element, it will call push operation, and when you take any element out of the stack, it will call a pop operation. In above figure, although item 3 was kept at last, it was the first one to remove. This is exactly how the last in first out principle works. We can implement a stack in any programming languages such as C, C++, Java, Python or C#, but the specification is pretty much same here. So stack are used in various applications such as expression evolution, function calls via recursion and many algorithmic puzzles. Let's look at some key examples and operations of stacks. So basically there are five operations which are performed on stack. First one is push. When you add any new element, it will call a push operation. If you remove any element from the top, then it will call a pop operation. When there is nothing in stack, or if you want to check the stack is empty or not, then you will have to apply is empty operation. If you want to check that stack is full or not, so you have to use is full operation. And if you only want to return the top element, then pick is the correct operation. So if we understand push operation, the process of putting a new element onto the stack is known as a push operation. So if we want to understand push operation step by step, then in step 1, first we have to check whether the stack is full or not. If stack is full, then it will produce an error and exit. But if stack is empty, there is some space for element, then we have to check or increment the top element or top point to the empty stack. So in step 4, if the stack is empty or if stack have some space, then we add the element on the shown location where the top pointer is pointing and return to the success. So algorithm for push operation is in step 1 we have to start. In step 2 we store the element to push into array. We have to check whether the stack is full or not. If stack is full, then we have to exit. Otherwise, we have to increment our top pointer by 1. And when the top pointer is written on that particular location, we will save our new element. Now we discuss about pop operation. Accessing the content while removing it from the stack is known as pop operation. In an array implementation of pop operation, top is decremented to a lower position in stack to point to the next value. But in linked list implementation, pop actually removes data element and deallocates memory space. A pop operation may involve the following step. The first step is very simple. We have to check whether the stack is empty or not. If stack is empty, there is nothing inside, then we can not able to remove anything from it. So in first step, we have to check whether the stack is empty or not. If stack is empty, then it will produce an error and exit. In step 3, whether the stack is not empty, in that condition, we access the data element in which top is pointing, because we have to remove the top element. So we remove the top element and decrease the pointer by 1 and return to the success. So algorithm for pop is simple. Step 1 is start, and in second step we have to check whether the stack is empty or not. For that we have to check whether the top pointer is at -1 or not. If top pointer is not at -1, that means stack is not empty and there are some elements in stack. So we will pop out an element and reduce the top pointer by 1 and stop the algorithm. Now we analysis the stack operation. So we know that push operation, it will take one. The time complexity of push operation is 1. The time complexity of pop operation is also 1. The top operation will also have time complexity of 1. And in search case, we have to search for particular element in all the stacks. So time complexity of search operation will become n. Now we discuss applications of stack. Then stack is used at many places like polish notation, reverse polish notation, recursive